Okay, so I'm doing the review packet. This is the review for topic 4B assessment. So this is covering our lessons on 4-4 and 4-5, where we did graphing an inequality as well as graphing a system of inequalities. And then there's also some old material that's on the actual test. I may do that in a separate video. So this particular video is only going to go over how to graph an inequality in a system of inequalities. It's going to go over how to write a linear inequality from a graph. It's going to go over how to write a linear inequality from a word problem. And then it's going to go over how to interpret solutions of an inequality, which basically means it's going to give you an ordered pair and ask you, is this a solution or not to the particular system of inequalities. So the first number I'm doing, we've already done a lot of these, by the way. We didn't really graph any on our review day, so I'm going to graph number, I guess I'll do number 9. No, I'm going to do number 7, because that has both types of problems in it. So this is number 7. Here's my pen. Oh, there it is. All right, so here's the problem. Number 7. Y less than or equal to x plus 4. And then the second equation is 2x plus y less than or equal to -4. Real quick before I do this, if you only have one equation, then you're only going to graph one line. So I think 1 through 6 are only one equation. If you have 2 equations, then you're going to wind up graphing 2 lines. That's the definition of a system of inequalities. I should say inequalities, not equations. I have 2 equations, so I'll wind up graphing 2 lines. All right, so we're going to do this first line, I'm going to do in blue. Second line, I'm going to do in red. Okay? So my first step, on the top equation, if you'll notice, it's already in slope-intercept form. Basically, that just means that y is all by itself. So if y is all by itself, I need to find the y-intercept. Right there. I need to then plot that on the graph. So first step is plot the y-intercept on the graph. So +4, it's a little tricky to see this graph, I think, at least on my screen. But if this is the origin right here, hopefully you see that blue point, then I go up to the +4. So that right there is +4, right? I'm going to erase this line right here. So I'm just showing you that with the origin. Okay, so that's my first step. I plot the y-intercept. Again, the y-intercept is where the line that I'm going to draw crosses over the y-axis, which is the line that goes straight up and down right there in the middle of the screen. Next, I need to come up with my rise over my run. So if I write rise over run, I'm not sure when I'm going to solve the other one. I'm going to have to delete this. So if I write rise over run, I need to look at the rate of change that's in the inequality. The rate of change is where the x is. It's the number in front of it, which since I don't have a number there, that means it's a 1. So if my rise over my run is 1, I just put that over 1, and that now gives me the rise over the run. So from this particular point, I'm going to go up 1 and over 1, and that gives me a dot right there. And then I could actually keep going up 1 and over 1, and up 1 and over 1, and that allows me to make a straighter line. So these are some of my points. I'm not going to worry about using the straight line tool. It should come out fairly straight with this one. It wasn't super difficult graph. All right, so there's my somewhat straight line, right? All right, so that's my line. The next thing I need to check is that line going to stay as a straight line, or is it going to become a dotted line? So the way I check that is I look at the inequality sign. So it says y is less than or equal to x plus 4. 1x plus 4 technically is the way I have it written down. Well, if that is less than or equal to, so that's a 1. 1x plus 4. So if it is less than or equal to, that means that is going to stay as a solid line. If it would have just been less than, then I would need to change it to a dotted line, but that's not the case in this particular situation. So my last step, so my line is done. I've made the line. My last step is I need to figure out which side do I need to shade. Well, in this particular equation, I need to shade the side that is, again, it says y is less than or equal to. Less than means below. Remember we talked about that at length? If I'm saying less than, and again, the key is y has got to be all by itself in order to use this method. So I can't do this on the bottom equation, but I can do it on the top equation. So if y is less than or equal to x plus 4, that means I'm going to shade this bottom section. So I'm going to shade all through here, because it's less than or equal to is below. And again, the line is solid because the equal to. All right, so there's my first line, done. That's the blue line. The area shaded is the solution set just for that blue line. Now, I need to do the second line. So I'm going to do the second line. I'm going to use red, and then I'll shade it blue. Probably should have done the other way. All right, so for the second line, I do not have y all by itself. All right, so I'm going to need to graph it using the other method, which is plugging in 0 for x, solving for y, and then plugging in 0 for y, solving for x. So I'm doing this one down below. So first I'm going to say let x equal 0. And then I'm going to just replace x with 0. So 2 times 0 plus y less than or equal to negative 4. That cancels out. I get y less than or equal to negative 4. So my first point is 0 because I made x equal 0. And then negative 4. I'm going to plot that point. So 0, negative 4 is down here. All right, so that's my first point. Now I do the same thing, only I let y equal 0. All right, well, if y equals 0, now I still have the 2x, but I say plus 0 is less than or equal to negative 4. Now divide by 2, then I got to divide by 2 over here. And I would get, so that all goes away, I get x is less than or equal to negative 2. So negative 4 divided by positive 2 is negative 2. So now my second coordinate, or ordered pair, is negative 2, comma 0. So now I plot that. So negative 2, comma 0 is right there. So now, to the best of my ability, I'm going to try to draw a straight line through those 2 points. So kind of, I would get another point right there. So now, if I drew a straight line through that, that would be right through there. Oopsies. I'm off track already. Alright, so it's a little crooked, but it'll be fine for this. Alright, so that would be my second line. Again, I need to check and see if it stays solid or if it should be dashed. Well, I have less than or equal to in this bottom equation also. So right there, you see I have under above that the equal to part, which means that line stays solid as well. Finally, last but certainly not least, I need to shade the correct region. So I'm going to use blue for this. I cannot just look at that symbol. So again, I cannot look at this symbol right here and just say, oh, okay, well, it's going to be below the line because it's less than or equal to. Now, sometimes that will still work because obviously you only have 2 possible sides to shade, so that might still work sometimes, but you can't just do it that way if you have the x over here with the y. You can't just go based on it being, less than meaning underneath and greater than meaning above. So what I have to do is I have to plug in 0, 0 to test it. So I'm going to plug in this point right here, 0, 0 into the equation. So I get 2 times 0 plus 0 is less than or equal to negative 4. I solve it out, that goes away. I get 0 is less than or equal to negative 4. Is that true? No, that is not true. 0 is not less than or equal to negative 4. So that means 0, 0 is not a solution, which should mean that the other side is the correct side to shade. So I'm shading this other side. Oh, shoot, I did it on the wrong line. So 0, 0 was not a solution, which means I need to shade this side. And I'm going to test that out in a second by plugging in a number that is part of the solution and see if it works. So all of this green area and blue, so the green and blue, should be a solution for the red line. So if I just really quickly, and I'm doing this in my head, you guys don't have to worry about this, but if I test, we'll say negative 4, 1 in the original equation, negative 4 would be negative 8, plus 1 would be negative 5. Yes, that would work. So that is correctly shaded. I could also test negative 3, 0, and that would also work. So yes, I did it correctly. All right, so the last thing is, to wrap it up, the area that is in green, that means technically that area in green was shaded blue and it was shaded yellow. It meets both of the requirements. It meets both equations. So that is the solution in green. The blue only meets one of the two requirements. It meets the requirement for the top equation. Wait, no, I'm sorry. The blue shaded region meets the requirements for the bottom equation. That was the red one. So the yellow also only meets one of the requirements for one of the equations. So the white part doesn't meet the requirements for any of the equations. That's because we didn't shade that yellow or blue. So it doesn't, none of those points would fit for either of the equations in that picture. All right, so that was number 7 that I just worked out on the front page. So now I'm going to go down and I'm going to do number 14, just because frankly 14 is really hard to see. The copy didn't come out very well. You have to create an equation, a system of equations from that line. I'm sorry, from that from the two lines. So I have to create a linear inequality, a linear system of inequalities from that graph. So basically that just means I'm creating two equations, two inequalities from the graph that they gave me. And I know it's two equations because I can kind of tell they're two lines. Let's see if I can do this one. It's not going to be great on here, but I think I can do it. Yeah, so right here, so we're doing this particular problem. Let me get rid of some of this stuff down here. It doesn't work great in this application, so it takes a little while. All right, that's good. All right, so I'm looking at this particular graph on the left. Now you can see it's much easier to read. That's why I'm doing this one. I have two lines. Two lines is going to mean two equations. So I'm going to kind of label one line the green line. So this is going to be my green line right here. So I'll do that one in green. And then the other line will be my blue line. So that one will be my blue line. I'll do that equation in blue. We'll start with blue since I still have blue in mind. Oh boy, that's a really hard one to do. Because they're kind of forcing you. Well, actually, what am I doing? See, that's just, oh boy, I don't like this one. The lines both go off the graph. Big time off the graph. So that is not a good. I'm still going to try to do it. You can't even tell where they intersect though, so it's, I'm not sure why in the world they would give you a problem like that. You would have to go through a ton of solving. So we're just going to estimate in this. So again, for the blue line, I'm just going to say that right here is -8. And I'm going to make that my starting point for the blue line. So my B value for the blue line is -8. So that's the first thing I write down is -8. Now I'm going to mark every point that is right on the corner of an X. So if you notice, all of these points go right through the corner of a square. So all of these go right through the corner of a square. So now I need to do my rise over my run, which I can do from any of those points that I just created. I need to go from one point to another point, see how far up or down I go, and then how far left or right. I'm just going to take the top two. So from the very top point, just underneath the blue, so that point right there, I'm going to go from that point, and I'm going to count to see how far down and over it takes me to get to that point. So I go down 1, 2, 3, 1, 2, 3, and then over 1. So if I go down 3 and over 1, down 3 is a -3, don't forget that. Over 1 is a +1. So basically my rate of change to go from this point to this point is -3 over 1, or just -3. So that means I write that down, and I just put the X there, because the X is always going to be in the equation. I also know Y is going to be in the equation, so I can write that. My last step is I just need to figure out what is the symbol I need to use. Is it going to be greater than, less than, greater than or equal to, less than or equal to? Well, I see the line is solid, right? So this blue line right here is solid. So I know it's going to have an equal to part to it, so I can just write that in. I also look at it, and I know that I am shading I'm shading above that line. Because if I take any of these blue points, especially the blue points down toward the bottom of the graph, the shaded area is above those points. So for this point right here, the shaded area is above it. For this point right here, the shaded area is above it. Again, for this point right here, the shaded area is above it. So if it's above, we said above means greater than, so that's my symbol. So there's one equation done. Now let's look at the green line. Again, this is the green line right here. I'm going to do the same thing. My starting point, I'm going to estimate, is +8. So I'm going to write +8 plus 8. Now I'm going to put a dot everywhere where that line goes through the corners of squares, which in this case is a lot of points. It's kind of going through, so it also goes through that same point right there. Goes through that point, goes through that point, goes through that point. So my next step is I write rise over run. And I'm just going to say, okay, well, how far do I have to go from one green point? So I'll start, we'll say, with this green point. I'm not going to draw the arrows in. Hopefully you understand what I'm doing. I'm going to go from the green point that is pretty much on top of the 7 to the green point that is left of the 6 down here. So I go down 1 and I go left 1. Or I could start all the way over here at that one, and I could go up 1 and right 1. Let's do that. Up 1 and right 1. If I go up 1, then that's +1. If I go to the right 1, then that is +1 as well. So I went from this point right here to this point right there. And that gave me up 1, right 1, which is 1 over 1. So that means, and again, you don't have to write the 1. I'm going to go ahead and write it. That means it's 1x. Really, you could just write x there. I know I'm going to have y over here. The line is also solid, so this green line is also solid. So that means I'm going to have this equal to part. And then, last but not least, is the shading above or below the line. Well, if this is the line where all these green dots are, the shading is below those dots. So anywhere I look at the dots, the shading is below those dots if I'm looking at only the shaded part. So that means if it's below, it has to be less than. The reason why there's such a small shaded region is because they're only showing you the solution. This shaded region is shaded twice. It's shaded for both lines. So it's above the blue line and below the green line. they didn't show you all the other shaded regions. So for example, they didn't show you the blue and the yellow. If you look at what I did before, they only showed you the green. So this whole shaded region represents the green if I would have done it in my blue and my yellow highlight. Okay, so there's that one done. These are your two equations up here, right here. These were your two equations. That's the system of inequalities right there. All right, so we did the word problem ones 15 and 16, so I'm not going to do those. On 17 and 18, we actually did some of these, but I'm going to kind of go back over how you do it. Boy, it's going to take a minute to erase, unfortunately. So all you do, I'm going to kind of talk while I erase. It's telling you to interpret the solutions of a linear equation. All that really means in this particular case is, are these points that they've given you, so A, B, C, D, are those solutions to the linear inequality above? Y is greater than or equal to 4x subtract 5. Are they solutions? Well, we can tell that a couple of ways. If we wanted, we could graph it, and then we could shade it. And if those solutions are in the shaded region, then they would be solutions. Because any point that's in the shaded region is a solution. Now, I'm not going to graph it. I'm going to show you the other way to do it. Doesn't matter which way you do it on the test. I'll give you graph paper. I am just going to take this point right here. And I'm going to say, well, if that is a solution to this equation, then when I plug those two numbers in, it should make that equation true if it's a solution. So I'm just going to say, okay, well, I'm going to plug 4 in for y. So this 4 right here, I plugged in for the y right there. And then I'm going to say, well, that's got to be greater than or equal to. So again, I put 4, and that's the 4 right here. That's just stay there. That just comes straight from the equation. Now I replace x with 3. So I'm taking this value right here and replacing it for x right there. And then I just say subtract 5, which just comes from the rest of the equation. And I get 4 is greater than or equal to 12 subtract 5. So 12 subtract 5 is 7. Well, is 4 greater than or equal to 7? No, 4 is not greater than or equal to 7. So that means if that's not true, that is not a solution because it didn't work out. The math just didn't work out. So I do that same thing for all of these. If it doesn't work out, then it's not a solution. If it does work out, and if I get an answer, a final answer that makes sense, that is true, then that is a solution. All right? I'll give you a hint. I believe there's only one solution out of those 4 options. So you do the same thing for number 18. You're just going to plug in those numbers into the 2y plus 6 is less than 8x. You could graph it if you wanted to, but that's definitely a tougher one to graph. 19 is pretty complex. That's really a whole lesson on its own. The constraints just mean, in this case, it says, do both of your numbers have to be greater than or equal to 0? Like, do they both have to be positive numbers, or could they be 0? In this one, it's saying the same, or does just x have to be greater than 0, or equal to 0? Or does just y have to be greater than or equal to 0? And then finally, or none of those is true. There's no constraint. X and y could be any number you want. I'll give you a quick hint. If you think about the problem and it doesn't make sense to have negative numbers, like for example, when we're traveling and we're going distance, there's no negative distance. So the constraint would be that those numbers could not be negative. I'm not going to go over that whole thing, though. That's pretty complex to try to do on a video. Oh, again, this is an easy one. Shaded region, you need to figure out which of these 4 regions. So this is region 1. I have to do it in color, I guess. This is region 1 right here. So this whole area is region 1. This is region 2. All of this. And then this is region 3, this little section right here. And then technically, I guess you have a region 4, which is this little section right here that's white. One of those regions is the area where both graphs overlap, where both shaded regions overlap, and you have to figure out which one it is. That can be a little tricky because they don't give you the equation, but there's only one that works. Like, if you look at this region in red, well, clearly the region in red has to do with the dashed line, and it is below the dashed line. So the region in red really is telling you that all of this, boy, it's so hard to explain this on video. It's telling you that all of this is shaded for that dotted line, that dashed line. But technically, if this is shaded, then all of this is shaded also. Because all of the area underneath the dashed line would have to be shaded. If part of it is shaded at all, it has to be shaded. All right, well then let's look at the area in blue. The area in blue means all of this is shaded, and we're talking about the solid line now. Well, if all of this is shaded underneath the solid line, then all of this has to be shaded under the solid line also. So the area that overlaps would be all of this area in green. If you're not following this, again, it's a tough one to review. I wish they would have used different colors, but unfortunately, I guess they can't do that. So I'm going to look at all of these different points down here. If these points are in the green region, which is based on the boundaries right here, if they're in the green region, then they are solutions. The tricky part is if they're on a dashed line, so if one of these points, if any of these points fell on this dashed line up here, so that was the dashed line, I kind of colored over it. If those points fell on the dashed line, they would not be solutions because we don't include the points on a dashed line as solutions, only the points on a solid line. And it looks like 5, 1 would be on there. So for example, this point right here, it's hard to see, but this point right here, that would be 5, 1, which is not in our solution set, but that would be on the dashed line, and it would not be a solution. So if you see any of these, again, any of these that are in the region that is outlined by green, those would be solutions, because that's the area where we shaded twice, the shading overlap. If they were on the solid line, so this really dark green area over here, that's a solid line. If a point falls on that line, it is a solution. I'm going to try to go over that one in class. Hopefully enough people are going to be in class where we can talk about that one. If not, then hopefully that helps. And then word problems. I really don't think these word problems are too bad. Actually, I don't think they're bad at all. I'm only going to do number 24. The other ones, I think, are pretty similar to 24, pretty easy. And I did one of them in class. I know it was 3rd and 4th grade for people over here. So I need to figure out what are my requirements in this word problem. What are the things that I have to meet? That's what a requirement is. If it's telling me I have to do something, that's a requirement, and that's going to become my equation. My variables are going to be based on the information I don't know. So I know that international blends, so right there, I'm going to do different. So international blends are 850. So I'm going to circle that in red. Everything that has to do with international blends, I'm circling in red. I know that house blends, so this is just has to do with coffee. Don't worry too much about what it means. They're just different kinds of coffee. So I know house blends are $6. That's the cost. So, oh, and I have $60 to spend, and that's kind of a combination of both the two different kind of coffees. So I'm going to buy some of one kind of coffee, and I'm going to buy some of another kind of coffee. But when I add the total cost of all the coffee up, it's going to have to be less or equal to that $60, because that's my budget. Well, we've talked about it in class. If you have a budget, then that's always going to be kind of at the end of the equation, and you need to be less than or equal to your budget. So we've gone over that many times. You shouldn't have a problem with that. So next, I want to just say, okay, well, I know I need to come up with some variables. What are my variables going to be? It doesn't tell you to use any particular variable for anything. So I'm actually going to use different, well, I'll use X and Y. So I'm going to say that X is going to represent, and I already have money involved, so if I know what the cost is, then most likely my variable is not going to stand for cost. So it's going to have to stand for quantity. That's typically the way it works. The variable is either going to be cost or quantity if you're dealing with money in the equation. So what is the quantity? It looks like how many packages, because it says right here per package, right? And then per package. So the number of packages is going to be my quantity. So X, I'm going to make the international blend. So the number, I guess I'll say packages of, and I'm going to shorten this up just to say international blends. So that's my X. And then that means Y has to be the number of packages of the other kind of coffee, which is house. Oops. Packages of house blends. That's kind of the hardest part normally, is coming up with what your variables are. Well, I know if a package of house blend is $8.50, that $8.50, this number right here, it's associated with international blends, right? Well, all I need to do then is match that up with the variable that represents international blends. So right here, international blends is X. So I just need to say $8.50. I have to really write this skinny to fit it in. So $8.50 times X is going to represent how much I spend on international coffee. Well, now I just do the same thing, but I do it with this $6 here. So if $6 represents the house blends, I'm just going to say $6, and then my Y is house blends, then that needs to be 6Y. And ultimately, my math that I'm doing is I'm adding the money together. So however much my international blends cost, plus how much my house blends cost. And that amount has to be less than or equal to 60. So there's one of my requirements now, my budget. The last requirement, read through it, the only other thing it says is that I need at least 3 packages of the house blend. So that's a different requirement. So I need at least 3 packages. It doesn't say anything about how many packages of international blend I need. It says I want some of both, so I do want some international blends, but I need at least 3 packages of house blends. This is actually not a good word problem, because technically there's a third requirement. We're not going to do 3, we're just going to do 2. So if I need at least 3 packages of house blends, again, house blends are down here, so Y is going to be in the formula. X is not, just Y, because that's the only requirement is house blends. So Y, which again represents the number of packages, my number of packages has to be at least 3. All right, well, at least means greater than or equal to. It could be more than 3, or it could be equal to 3. And then 3. There you go. That's your second inequality. So then from there we would graph that. Remember, graphing this is a little tricky. It winds up becoming a horizontal line, because you would say if this was my graph and 3 was down here and then 3 was up here, so that's positive 3, negative 3, positive 3, negative 3. So then all of these would be the other numbers in between there. Well, Y is greater than positive 3 where? Well, it's greater than positive 3, greater than or equal to, actually I'm going to use a different color, anywhere above that line. So that's where Y is greater than positive 3. That other equation, though, will be a little trickier. I would have to divide all that stuff out, come up with the y-intercepts. Basically, it looks like Well, that won't even fit on the fake graph that I just made. It would come out to go through 0, 10, and so 1 point would be 0, 10, 0, 10. This is just for you if you're trying it at your home. And then the other one would come out to be whatever 60 divided by 8.5 is, divided by 8.5. So do the math on that. So divide 60 by 8.5 and then comma 0. So 8 goes into 60 like 7 times. So it probably comes out to be 6 point something comma 0 would be my guess. You can do the math on that one. The main thing is I want you to get this part correct over here. I want you to be able to write these equations for the word problems. All right, so that's the end of the video. That was the bell. I gotta go.